Hi, this is Tom, and welcome to Lesson 29, Counting and Repetition. So, in this video, what we'd like to do is to continue the idea of permutations. And in a permutation, let's make a few notes. In a permutation, the order matters. That's a simple phrase that you'll hear. Permutation, order, in a permutation, the order matters. But what if the order doesn't matter? That's the question we're going to take a look at today. For example, when you're maybe making a lineup for a team and the position does matter, who plays, then the permutation, then that would be a permutation. Or in our previous example, our books on a shelf. But here, what we're going to look at today is called a combination. A combination. And in this case, the order does not matter. Does not matter. And the most famous example would be cards, playing cards, or playing a game of cards. And the idea being that when the cards are dealt, they're dealt face down. A game, oops, I should write and then talk. Play a game of cards. Because initially the cards are face down, but then you can turn them over and you can move them around. But you still have the same hand regardless of the order of the cards. So here we go. We're going to see if this makes sense. So in mathematics, a word is an arrangement of characters. These could be letters, numbers, could be arrows. It could be even like typesetting symbols and like the ampersand or the pound sign or an exclamation mark or an at sign. So when we talk about a word, we're just talking about an arrangement of characters, and it may not even be something that you'd find in the dictionary. So let's see how many words we can write, and we'll write this down. How many words are possible from C, from SEA? Question mark. All right, this is how we attack this. So what I'm going to do first is I'm going to write out just ways I could arrange C. For example, I could write C, that's one, S-E-A. Then maybe I could change the E and the A, so it'd be S-A-E. And then maybe we could start with the E. So let's start with the E now. So I start with the E, then I could write S-A, and I could write A-S. Or I could start with the A, and I could write S-E or A-E-S. And I think that's it, and it looks like we have 6 different words. 6 different words. Okay, now though, what if I didn't draw the picture? Like, what if it was a bigger word than this? Well, like statistics or something. Well, we'll hold off on that, but let's just see if we can come up with another strategy. So first off, because all the letters are different, let's see, you only have a 3-letter word. So in the first position, how many letters could we put? Well, we could put the S, the E, or the A, so that was 3 letters. But for example, let's maybe say we're working on this word, E-A-S. Well, once I've used that first E, how many letters are available? Well, there's 2. There's A or there's S. So now I'd say there's 2 letters available. But once I put an A down, there's only 1 letter available. That's the S. And the multiplication rule tells me to multiply the results. 3 times 2 times 1, well, that's 6. And so this works. This is if the letters are all different. If the letters are all different. Okay, now let's try how many words. I'm going to just copy this. This is so nice there. I'm going to leave that. I copy it. I'm going to put it down here. And let's just move it over. Put it right about there. Okay, and now what we're going to do is we're going to do just one little thing. How many words are possible from C, S-E-E? Well, here we go. First off, let's treat this as if all the letters are different. For example, if I write S-E-E, I could also write S-E-E. And we may say, but that's no different. And you're right. But in a way it is, because I actually switched the order of the 2 E's. So now I could start with an E. Maybe I did E-S-E. Well, I could also then write E-S-E. Wait a minute. Again, switching the E's. Or I could write E-E-S. Or I could write that as E-E-S. And again, I switched the E's. So when I did that, if I look more closely, S-E-E and S-E-E, that's really just one word. And so is easy and easy. And finally, so are the E's. So the answer in this case is only 3. But how could I get that? That doesn't make sense. Well, let's do this. Suppose I have a 2-letter word. So let's consider a 2-letter word. How about 2, T-O? Well, notice that then I could write T-O, or I could write O-T. So wait a minute, if we use the same, now notice that T-O, those are different letters. So in the first spot, I could put two different letters. In the second spot, I could put 1. Well, wait a minute, that's just 2 times 1, which is, oops, I should write it. That's just 2 factorial. So wait a minute. Notice that when you have a duplicate, it makes a 2 factorial, which is also 2. It makes 2 copies. So here's 1 and here's the second copy. Here's the first one and here's the second copy. The first one and the second copy. So in other words, we just need to divide out those extra copies. So if all the letters were different, like in C, S, E, A, we'd say, well, there's 3 factorial different words. However, we have repeats. And in this case, we repeat E's, so we need to divide by all the groups that those E's can write that are the same. And this is 3 times 2 times 1 over 2 times 1. And notice that the 2 times 1s will cancel, and the result is 3, like we would expect. We're going to try one more example, and hopefully this is beginning to seem easy. So, let's use that. Let's try this. How many words? I should have had a question mark there. Let's just use this one again. Let's come down here. And let's change this just a bit. What about seams? Well, here's how we do this. We think of it if all letters are different, then there would be 5 factorial words. Because there's 1, 2, 3, 4, 5 letters in seams. Now wait a minute though. I have the E's repeat. So for the E's, we need to divide by 2 factorial. But if we look closely, notice there's also an S at the beginning of seams and 1 at the end. Divide by 2 factorial for the E's and for the S's. So the problem becomes 5 factorial divided by 2 factorial for the E's divided by the 2 factorial for the S's. And so I'm going to do this by hand. You could try this on your calculator. So that's 2 times 1 times, oops, 1 times 2 times 1. Oh, and look at this. 2 times 2, that's a 4. 1 times 1 is a 1. So that's going to give me 5 times 3, which is 15 times 2, or 30 different words from seams. We're going to stop there, and then the next video, we're going to take this even one step further. Thanks for watching, and see you in a bit.